In this video, I'm going to be producing this portion of the handle to wind the arbor in my clock mainspring winder. So there's milling machine work producing the radius ends, there's shaper work on the tapered sides that meet these radii, and there's shaper work on the flat surfaces there. There's lathe work to produce this domed head bolt, all of which, in conjunction with these little pointy set screws, allows me to engage the handle into the end of the arbor for that clock mainspring winder. You can see the job's mounted on a circular parallel. Inside that there's a 1/2" spigot going into the rotary table, and that's my little 3/16 spigot protruding out the top of the 1/2" one, having gone through the job. Clamps are holding it down. They're the original BCA clamps that come with the machine. So what I'm going to do now is wind the job back and bring you back in for another pass on the job. Set my depth of cut. And start rotating the table. And then for the final pass, I'll do a 0.1 mil depth of cut, which is about 0.04 of an inch, just as a final clean-up pass, and that'll then be at the finished radius. Quickly clean that off. That's not a bad finish. I'm quite happy with that. So I'm not going to do a climb pass back, because I don't want to impact any swarf into the surface. So what I'm going to do now is break down the job and turn it round and do the other end. So I brought it back again. I've reversed the job. I've had to remove the little circular parallel that I used at the front there, because it's too big for the radius I'm going to end up with. So this has exposed the spigot that I said about that goes into the central bore in the rotary table. So that's 1/2" diameter, and into that I've sunk a 3/16 of an inch spigot, and that goes through the reamed hole in the workpiece to replicate what I had the first time. You can see I've set it up on conventional parallels this time, and again have this spigoted system into another spigot that locates in one of those holes there, and that gives me my central position between these two 90-degree T-slots. So basically I've replicated the original setup, but this time for a smaller radius. So now do a bit of roughing out on this. So I'll be drawing the table this way to set the depth of cut and progressing as I did before. So the final depth of cut will be 0.1 of a millimetre, so about 4/1000ths of an inch. And I'll probably stop at the far end rather than bring the cutter back on a climb milling cut, because I don't want to impact any of these little bits of aluminium swarf into the finish. Of course, what I should have said was that I wasn't going to bring it back doing a conventional milling cut, because previously going the other way actually was a climb cut, where you're bringing the work into the rotation of the cutter. It's a better way of cutting on these lighter machines. I'll now break down this job from the machine, because although I could reset it and try and get the angles right to mill the sides to get the contact point with the end of my 180-degree arc around the radius, I'm frankly more comfortable doing that on the shaper. There's quite a lot of material to remove, so it'd be quite a long time on the milling machine, and I don't really like working to scribed lines, and even if I did, it's very hard to see them when you're trying to look down from above in this sort of cramped space. So it's easier to do the job on the shaper, I think. So that's where I'll be next. Right, before I wander off to the shaper with this tentative handle, it's now off the BCA jig bore, as you can see. I just thought I'd explain a little bit about my ideas of setup. What I've done is I've popped back in the 2 locating spigots. These are little silver steel dowels. I've aimed by moving the cutter through 180 degrees for the centre line of the cutter to produce that as the highest point at 180 degrees apart. That should be a radius of 15 millimeters, giving a diameter there of 30 millimeters, and that should be 16 millimeters across, giving a radius of 8 millimeters. By keeping these spigots or dowels in the locating holes, I can pop it into the shape of vice with the jaws running like that. But in order to get that line level, and it is only a marking outline, it's not done for any sort of idea of accurate working to, the crucial thing is to work to these 2 high points. So you have one end which is 16 millimeter radius, the other end 8 millimeter radius, so it's all probably already become apparent to everybody that I need to raise that one by 7 millimeters in order for that line to be level. So by putting a gauge block or similar packing between that and the top of the shaper jaw, with that sat on the top of the shaper jaw, that should achieve what I'm aiming to get there when I remove all the metal above that line, that notional line, as I say, because what I'm actually doing is working on dimensions and aiming not to have too much or ideally any step there. So by the next time you do see this, it will be in the shape of ice, and if you see lumps under there, that's why. It gives you a slightly better view. So a rounded nose cutting tool, high-speed steel cutting tool, and I'm not looking for a perfect finish at this stage because I'm just going to be roughing out, but in the latter stages obviously I will want a decent finish if I can possibly achieve it. If you see me painting anything on, that's going to be paraffin as a lubricant or cutting fluid. If you can excuse a little bit of wobbly handheld footage, I'll just take you in a little bit closer to the job. Hopefully gives you a little bit closer and better view of the setup. also shows the previous machining that I've done on the rotary table on the milling machine. You can see the type of tool I'm using. And for anybody not that used to shapers, this arm here is moved further or closer to the centre of this rotating element here, and that gives you your step over, which is achieved by this arm here going forwards to a ratcheting mechanism here, and this ratchet here, operated by that knob on the top, when it's in its working position, which is either traversing that way or traversing the table that way and back to neutral, there's a sprung loaded pawl in here, and as that arm taking the rotary motion from back here, as that pushes forwards, this ratchet arrangement clicks over either 1, 2 or 3 teeth to give you a step over, because what it is doing is driving the feed screw here for the main work table here, to which, by the T-slots and a slightly cranky setup, I've attached my vise. So hopefully that hasn't made you feel too ill with it all wobbling about. The down feed here on the cutting head is what provides your depth of cut. It's a metric machine, so these are millimeters and these are 0.1 of a millimeter increments. The clapper box here, as you doubtless know if you're used to shapers, allows the tool to be clear of the workpiece on the return stroke and down for the cutting forward stroke. And again, anybody who knows anything about shapers will be hopefully reassured to know that I have turned the machine over by hand, so that the ram has come from the back of its stroke right forward and back again, to make sure that nothing like the ram itself here or any of the parts of the clapper box hit anything, because shapers are very, very unforgiving of mistakes. When it comes to collisions with workpieces, work holding or other bits of the machine, they take no prisoners, and bits get broken, or you get broken, or things fly around the workshop in a very alarming manner. So it's always worth doing that hand pass first. So I'll pop you back on the tripod and we'll see about actually doing some shaping. Mistake. done a quick confidence check that the 180-degree mark there at both ends does give the same reading up to this top surface as accurately as I can do with calipers, and given that it's a curved surface coming round on that direction and then mimicking the shape of the cutter as it comes away after the 180 point. But I appear to be on the right track. It may not be perfect, that will become apparent later. So a little bit more of the same 0.4mm cuts for the moment until I get a bit closer, at which point I'll reduce the depth of cut and reduce the step over on the traverse. Now I'm going to reduce the step over further, so I'm going to take that arm further in towards the centre of that rotation centre, and I'm now going to take very fine cuts as I creep towards where I want to be. Just a very smallest transition here still, but it is very slight. I've finished doing the shape work on this now. This is as it came off the shaper, except I've used a number 2 cut file just to break the edges. So very, very light chamfer there. But the rest of it is as machined. It's come out reasonably well. I'm quite happy with it. As I said, there's a little bit of a transition there, but it's very, very, I really can hardly feel that. That one's pretty much the same. The other end, slightly more noticeable, but it's only very slight. I'm pretty happy with that. A little bit of hand dressing, and that's just going to disappear and blend in really nicely, I hope. Finish overall, I'm reasonably happy with, to be honest. I will do a little bit of finishing work before it goes into use, no doubt, but I'm not sure it's actually necessary. Next stage is to increase the diameter of that hole there. The reason being that this has got to live on there. I could just use a bolt or screw like this, but that's the only one I've got in M12, and it's frankly pretty ropey quality. It's stainless steel, but it's really pretty rough. So rather than have that not be very happy with it, I'm going to take a piece of this hex bar, brass bar, and turn that into hopefully a slightly more attractive looking fitting. That will go through a washer which will come out of here, and those two in combination with a couple of pointed set screws which I'm going to let into there will be the means of retaining that on there. The set screws, as I mentioned before, are just to locate into these little grooves here so that the thing hasn't got any tendency to unwind itself at all, because that's just always going to be bad news if it happens. So that's the next stage for this. Well, I'm back at the lathe. I've hacksawed off a piece of my hexagon brass bar. I've cut it to a length so that as much of it can go in as possible and still leave me about an inch my job, inch and a quarter for the job I'm going to make. The idea being that because I can't pass this right through the spindle, I want a usable piece left for another job. So that's why it's at that length. So I'll get that into the chuck, but first of all, just talk quickly through what I'm going to do. I'll bring you a little bit closer because then it'll be a bit clearer on the metal, I think. The idea is that what I'm going to do is I'm going to face it off and then using the lead screw, because this doesn't have a graduated hand wheel on the carriage, use the lead screw so that I can go in a measured distance along here, which will be machined to a diameter of 12 millimeters or 0.475 of an inch. It's a imperial machine, so it will be 0.475 of an inch, and I'm traversing along 0.675. Excuse me. That diameter should fit the reamed hole in my handle, so I'll probably do a trial of that. And then do a trial fit on the handle, I expect. Once that's at the required diameter, I'll go along for 0.475 of an inch or 12 mil to slightly reduced diameter of 0.470 or 11.8 mil, because that portion's then going to have an M12 by 1.75 thread on it, which I'll do with a die because I'm not really set up for metric thread cutting on this machine. And it doesn't need to be a fantastic thread. It needs to be good enough to hold this into the spindle that it matches to. So that's going to leave me with a hex head so that I can actually tighten this into the handle. So get that nice and flat on the back face of the nut, as it were. Then when that's all done, the job will come out and I'll collet it, hold it in a collet the other way around. So what I'm going to be doing on this now shorter piece of metal is rough forming a curved head going back to the hexagon shape. So it won't just be a rough hexagon and then a flat, it'll have a little bit of a curve to it. Partly so that it looks nicer, and partly so if I catch my hand on it while I'm winding, it's not going to cut me. Fit, and that's a good sliding fit, which is what I wanted. Not too loose, not too tight. I said I'd come back when I'd finally found a 12mm die, which I have, nice Presto one. As you'll see from my rather old-fashioned die stock holder, I'm possibly the only person left without a tailstock die holder. But I haven't got one. Keep meaning to make one. Some of the ones I've seen for sale aren't great, so probably is a case of making one. So I'm going to show my approach. There's a couple of aspects to it which may or may not be of interest to people. One is I use a handle in the spindle. Made it quite some years ago, and by memory it's from a Hemingway kit, and I was actually quite pleased with it when I made it, and I still am. I enjoyed doing it. Then really nice drawings that came with it, and all in all, it wasn't the cheapest thing, but I think it was quite a nice way of going about it. Pop this into the back of the spindle, tighten it up, and when you do that, it draws this little tapered plug down, and that's pinned so that that will just draw down straight into the slot and won't spin. That expands that into this spindle, and it gives you a nice firm grip to turn with the handle. Makes all sorts of operations like this a whole load easier. Really well worth having, I think. I believe Myford did, or maybe even still do, make a handle, but I only found that out after I'd gone to the trouble of making one. As you may or may not remember, I had a slightly larger diameter section for the last 200 thou of this. So I've put two washers on, which are 100 thou thick each, so I don't have to worry about where the shoulder is. I can just go up until those engaged with the die, and I know I've gone far enough then. So I'll be turning the spindle by hand. This is my approach, arguably not the best, but that's how I'm going to do it. Position the handle onto there. The die now engages, and I can bring the tailstock up. And as I'm going to spin the handle, I'm going to turn the tailstock handle, and that will just supply gentle force to that to keep it true. I'm not driving it on or anything, it's drawing itself on, but I'm keeping this pressed behind it to keep everything as true as I reasonably can. So So I now have that ready for remounting. I'm going to mount it in a collet, so I'll come back when I've got the 3-jaw chuck off and a collet mounted up, and then I'll do the rest of this. As you can see, I've now mounted an ER25 collet holder onto the nose of the spindle, popped the job into a 12mm ER25 collet, and I will unceremoniously snip off the worst of that pit. I'll flatten that off. I haven't got to look for any finish on that whatsoever because I'm going to be machining that in a moment. The next stage after I've knocked that off is to use a roughing tool just to knock the corners off here a bit, and then the next tool you'll see appear is a form tool, and I'm going to attempt to avoid too much chatter and form hopefully a pleasing shape akin to that onto the nose of this fitting. As you can see, this looks remarkably like a worn out old file, which is exactly what it is. Really nice quality file back in its day many years ago, and what I've done is just grind out various shapes where I wanted to form a curved face on a washer or a fitting or something like that. It's fine in brass. It's not going to last very long, particularly in a harder steel, but in brass all you're really trying to do is avoid chatter when you're doing it. The tool life is pretty good in brass. This video ends with me having made these parts, but the follow-on will be in a second video because this just got too long making this to fit it all in one video. So please look out for the following video making these parts. Thanks for watching. Hope you enjoyed it.